while loop. So let's explain how this one conceptually works, right? So we'll have the keyword while, and then we'll have a Boolean expression here. So we introduced those, and then some statements here. Maybe statement, right? And more statements. Statement 1, statement 2, up to n statements. Preferably not more than like 8 to 10 lines of code in one loop, and one while loop is fine. So how does this work, right? So we will have an expression here, some condition, right? It true, evaluates to true or false. As long as this Boolean expression right here is true, these statements execute, okay? However, one catch is we need to have some statement that makes the Boolean expression false. Otherwise, the loop will never stop running, right? Unless you like crash the program, start the computer, restart the computer. So statement makes Boolean expression false. So we have to take care of that. And when that happens, then when it comes over here, it'll be false. So then it no longer executes the statements. It'll go on to other statements in our code. Okay, so that's conceptually how it works. While some Boolean expression is true, execute statement, and more statements. And then we have some code that will eventually make that Boolean expression false. When that happens, then the loop stops executing. Okay, so that's how that piece will work. For example, we can take a very simple example. Like we just want to display numbers, right? A list of numbers. So we have a function that will accept some value, and in that function we'll have a looping structure that displays the numbers from 0 to that number. Like if we do 3, then it'll be 0, 1, 2, 3, so it'll display that to screen. If we input 2, then we'll have 0, 1, 2. And how does it stop? Well, we need to write some code to set the Boolean expression and eventually make that condition false, okay? So let's see how we would code this piece, right? So we go here. And this one will help us just understand how the while loop works, right? So let me go into my code space. We're going to look at 3 different examples with the while loop. That way we get a very good solid understanding of how it works, okay? And then we'll introduce a different type of looping structure. So I think for now we are done with decision, so we can close all here, right click, close all. Go to our Explorer, Project Explorer, and we are starting a new example branch. So we go to repetition py, and this one we can't really test, okay, because this function will not return a value. It'll just display some value for us. That's fine. We can say display numbers, and whatever num we receive we'll use to display numbers from 0 to that number, assuming that they're going to give us a number. We're not checking to see if they really give us a number, but our users in this case are perfect. So again, we have a while, and then we have some Boolean expression. So we can say we need a counter, right? So we say counter equals 0. And then we say, well, counter, that's the Boolean expression. Well, counter less than equal to num, the Boolean expression, then execute some statements. Here, what do we want to do? We want to say print num. I mean, not print num, print CNT. And then we want to make sure that we make this eventually false. If we don't, then this loop just keeps on running and running and running, and we won't be able to stop it. So maybe we can show, just see what happens if we just use it, right? So we're going to call display numbers. Again, no test case for this one. It's just to introduce the loops. We display numbers. So repetition, display numbers. Say we want to display just 0, 1, 2, 3. Let me come up here, right here. Run it, but notice that like it just ran away, right? It's just, notice down here you see it flickering. So that's an infinite loop, right? Like, well, theoretically, we press Control C, then you can stop it. You have to click on the terminal, press Control C, and then the program will stop executing. So we need a statement that makes the Boolean expression false. So here, if counter is 0 and we say counter less than equal to num, then we want to be incrementing the counter for each iteration, right? So if we take this piece of code here and we bring it into here, we have that code. So we have CNT, and then we have the comparison CNT less than equal num, and then we have num, okay? And assuming num originally is 3, okay? So then we know that we will execute 0, 1, 2, 3 times. So originally count is 0. Let me do something. 1, 2, 3, 4 iterations, 4 loops, okay? So originally count is 0. So is 0 less than equal to num? True, right? That's true. So then the loop continues. This is always 3. Next step. We have count equal count plus 1. I didn't bring that over. So that'll be a statement right before it goes on to the next loop. Then it's 0, add 1, so count is 1. Is 1 less than equal to 3, right, which is num? Yes, so this is true. Over here it'll display value 0 and then value 1. And then we say, okay, increment count by 1. So 1 plus 1, 2. Is 2 less than equal to 3? Yes, that's true. This guy always stays 3. It would display 2. And then right before it goes on to the next loop, again, it says increment by 1. So now is 3 less than equal to 3? That's true. It outputs 3. On the 5th iteration, count 3 plus 1, 4. Is 4 less than equal to 3? So we know this is false. So then nothing is displayed. Loop exits. So that's how that loop is working. So I purposely did that so you can know how to trace it. Make sure you know how to trace a loop, because that's going to be on assignment and on quizzes. It'll help you understand how those loops work, and it'll make you understand them a lot better. You'll write better code. So we need CNT equals CNT plus 1. That's where we eventually make this Boolean expression false. Okay, so we say display numbers 3, count is 0, and then this loop will iterate 0, 1, 2, 3, and then it exits. So let's go back to main, and let me clear this piece here. Clear and run. Notice now we have 0, 1, 2, 3. Okay, and if we want to like see output to match what we have here, then we can do that. We're like, oh, okay, so maybe we should create this table in Python just to make sure that we understand what's going on. So we can put print statements here. We can say, okay, so we want to print count plus 1. That's the number of iterations, okay? And then we want to print we don't need string count, and then we want to print count less than equal to num. And finally, what do we print? Num, right? Just to keep track of num. So we have okay, so let me try to run it again. Go here, clear, run. So we have 1, 2, 3, 4, 0, 1, 2, 3, true, 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 3. Maybe what I should do is do it here, right? Otherwise, it's not gonna produce the output we want. So here, this is what we want. So let me go here and let's run it again. So notice now we do have the final output right here, and that matches the table because we had true, 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 false. Where did that come from? That comes from comparing CNT less than equal num, and if we look at the table, we have 1, 2, 3, 4, 5 iterations, and then we have 0, 1, 2, 3, 4, and we display 0, 1, 2, 3, 4. So let's go ahead and go back to code. Oops, not that one, this one. And that's what we have here. So that's how that loop is working. Questions here? Again, there's no test case here. We're just being introduced to loops, and I just wanted to create a simple example just to make sure that we understand how it's working. Okay, so no questions so far. Let me go to the next example, and this one is also a while loop, but we're just going to solve a different problem, and we will create a test case for this one. So we say we want to accept a number, and we want to return the sum of squares for that number, and we'll see how that works. So again, this is Boolean expression. And for this one, what we want to do is, for example, if we have the number 3, then we want, meaning like if we use sum of squares with argument 3, then we want 1 times 1 plus 2 times 2 plus 3 times 3 equal 14. So that's what we want to code. So to do that, we need to first create a variable that'll hold the summation, right? And then we want to make sure we return that variable. Okay, so that's sum of squares, and then we need the while loop to help us do the work. So how do we tackle this one? So again, we need to at least set this up, and then we need a Boolean expression here, right? So we need Boolean expression. Right here, a condition. So we can say, okay, so I need to go from 1 through 3, and how would I tackle this one? Anyone? How are we going to solve this one? Okay, we have some.
Sir.
Yeah.
I can take a stab at it. You can make a variable called I, and then you can just, while I is however many things you want to do, and then by the time I reaches that number, the loop will be done.
Which number?
So you have how many expressions is that? I joined late, so I don't know exactly what's going on, but
yeah. So this function accepts a number, and we want to return the sum of squares. Like if we use 3, then we want 1 times 1 plus 2 times, not minus, 2 times 2 plus 3 times 3 equals 14. So I what here on line 17 right here.
While I is probably less than, that's 3 expressions, right? So
less than,
you want it,
this one, the num, or than sum?
I'm sorry?
Which value do I use here, num or sum?
I would go with num.
Okay, num, less than num. Okay, so that's our Boolean expression. Okay, and then we need to, sum is like our tally variable, right? So here we can say sum has to be equal to sum itself plus what? We're trying to implement that code, a code that handles that math operation for us. How do we square a number?
I think num square, I think. That's num square.
Yeah, and in simple terms, what is that? Num squared is what? Num times num, right? Num times num.
Yeah.
So that's how we can square it. So we can say plus num times num. Okay. We still need a statement that makes the Boolean expression false. So what's that statement? Or
I
eventually,
equals-
right? Eventually we'll make it false.
I equals I plus 1.
Yeah, I equals I plus 1. So that will eventually make this Boolean expression false. Okay, so now we're ready for our test case. But before we do the test case, maybe we should trace this, or just this piece here. We should trace that code on a table here so that we understand what's going on. So okay, so let's see. So we have that. We don't need this piece or that piece or that piece. This one has to be there. Okay, so now we are ready. So we can say, okay, so we have the number of loops, and then we have the value of sum, and then we have the value of I, and then we have the Boolean expression I less than num, and that should do it, right? Maybe, yeah, that should do it. Okay, so we start with loop 1. Sum is 0, I is 0, and the value of num, assume it's 3. Okay, so num is 3. So I less than 3. I mean 0 less than 3, right? 0 less than 3, true. So then the loop executes, right? The statement, the loop executes, then we see sum equals sum plus num times num. So sum will stay at 0, and that's fine. And then we have I 0, 0 less than 3, okay. So then we have this statement here, I equals I plus 1, meaning add 1. We are in the second iteration. So first thing we do is test, is 1 less than 3 true? Yes, it's true. So now we say, okay, so what is sum? Sum is 0 plus num times num, so that's 0 plus 1. Okay, so now sum is 1. And before we go on to the next loop, this one will be changed to 1 plus 1. So by the time the next iteration will start, this will be value 2. So then we say 2 is 2 less than 3. Yes, true. Okay, so now we have sum. What is sum? 1. So we have 1 plus 2 times 2 equals 2 times 2, 4 plus 1, 5. Okay, and then we increment I by 1, so we have 3. 3 less than 3, false, right? So then we have a fourth iteration. If this is false, then the code doesn't execute and the value of sum is 5. So let's go back and look at our requirements. So we go into our requirements. Are we meeting the requirements? No, it should be 14. So what do we need to change here, right? So while you think of that, let's just validate that with a test case. So we can go to test case and just check our math. So we're like, oh, well, our test cases should help us. So we'll say def test sum of squares. And we have assert that if we use sum of squares with value 3, that should give us 14. Hover over this, select quick fix, and we add this piece, and notice sum of squares is there. Now we need to go into run decisions, run test, and we have to just point this to test examples dot d repetition, backspace here, control space, test repetition. So now this one should be test repetition 2. Okay, now we can run those test cases. Let me clear the terminal. Run. Let me see, 27 and not equal to 14. So we did obviously something wrong, right? Let me see here. Num. Okay, so that, yeah, that's like in Python, but I didn't want to do that yet because we haven't introduced it. So let's look at our code. So what do we have here? I less than num, sum equals sum plus num times num, I equals 1 plus 1. And what did the test case return for us? 27. How did it do that? Let's see here. Print sum, and let me run this main, and let's see what it does. Oops, I need to run sum of squares here. Actually, let me do something here. Test repetition. I'll make it one whole commit. Okay, display numbers, comment that piece out. Sum of squares, value 3, and let's run it. 9, 18, 27. So our logic is obviously incorrect. Okay, so sum equals sum plus num times num. Oh yeah, so here we're just continuously doing 3 times 3. So we're not doing this, right? So maybe we need another variable here. Which one should we use instead of num?
I,
right? So let's do I. Okay, that'll match our table. I times I. And let's go to the test case. Run test. Clear. Run. It's still failing. This is what we got on the table 5, right? So let's go and see what we need to fix here. We need to fix something in our code. Say again?
I think we need to add another I square.
That will probably not solve it. So let's go look at the table and see what's going on. We have 5, but what happens if this loop executes? So then we, assuming that this was true, right? So then we're like, okay, so then we have 5 plus 3 times 3, 9 plus 5, 14. So is that what our test case is giving us? 14. Oh, so we need to make sure we loop at least one more time. So what do we need? Less than, or do we need some other operator?
less than or equal to.
Less than or equal to, right? So here, if we use less than or equal to, then we'll get one more. We'll get to the num itself. And that should allow us to. So if we say no, then this should be equal to, equal to, equal to, equal to. So 3 less than equal to 3?
It's true.
It's true. So that means we get one more loop, and then we get this result that we're after. So if we go and run our test case, then it should be passing now. So go run test, run, and we are okay, right? This is output that I generated in the function, but here we're test sum of squares, and we are okay. So now what I'll do is I'll go back into the code and I'll remove this output, this one, print sum. And I'll run the test case again, but let me clear some clutter here. Clear, run the test case again. And we have sum of squares here. And it's working, right? So that's how test cases can guide you, like, to fix code problems. Let's see, let's create another assertion with value 4. So value 4, and 4 times 4, 16, plus 14, 30, right? So if we go and look at our math, assuming we were able to go an extra loop, then we have 14 plus 4 times 4, so 4 times 4 is 16, plus 14, 30. So let's run the test case to see if our function still works there. And it does. And we will do one more. We will do the number 5. So if we use 5, so that's 5 times 5, 25 plus 30, then we would have 55. And if you're like wondering what happened, we're assuming that we went an extra iteration. If we will go an extra iteration, then we would have 14, no, what's 30, right? We would have 30 plus 5 times 5, so that's 25 plus 30 equal to 55. And this one was 14 plus 4 times 4 equals 30, okay? If you're wondering where I got the values from, we're just assuming that the loop kept on going, but I don't want to like mess this one up because this one was just for value 3, just enough to like show you what's happening in each iteration. So let's go and run the test case. Run test, run, and we have test sum of squares. Okay, and that's how we could use a while loop to help us do some tabulation of values. Well, let me go here. Questions here? And there's still another way we can control a while loop, and that's by collecting some data from the keyboard. For example, we can ask the user, do you want to keep, or do you want to continue? And if they give us Y, then we continue. Any other character they send to the keyboard, we will exit the loop. Again, this one will not have a test case either, but we can see how we can control program flow with a loop and user input. So we'll say prompt user. And then we have a variable, maybe like keep going, and assume we say, yeah, keep going initially. So we can say while, and then we need a condition, right? So keep going equals Y, or keep going equals capital Y. So if they give us lowercase y or uppercase y, our loop will continue to ask him, do you want to keep on going? That's all we'll ask him, right? So that should be enough. So let's see, how do we do this? So we need somehow to make that Boolean expression false. So we can say, okay, keep going equals, and then we ask the user for some keyboard entry. So we say loop again, type Y or Y. And that's all. Like if we run this loop, then we'll see that we can control the input from the keyboard. I mean the loop from the keyboard. So we're like, okay, prompt user. Notice this function doesn't require any input from outside. So everything happens inside the function. So let's see what happens here. Clear output. Run. Loop again. Yes. Loop again, capital Y. Yes. Loop again. I'm in a hurry. I typed that. So notice anything that's not lower or uppercase Y, it will not loop. But if we do Y or capital Y, we'll keep on looping. Anything else, loop exits, right? So that's how you can control program flow. Like maybe you're creating a mini program, and now we're like, oh, we can capture user input, and from there we can control what our program does. Very simple example here, but this will apply for homework assignments when I ask you, like, the program continues until the user opts to quit, right? Meaning, oh, you have to get data from the keyboard, and you ask the user, like, do you want to continue? Yes or no. And questions here? Easy enough. So this one I didn't map because, I mean, this will either be true or false, and depending on the output we get from the keyboard, right? So I didn't trace the code. Okay, let me make this as one commit for while loop examples. Commit, and we commit it. Send it onto my repository, and then I can